Hi guys, I hope you're good since last video. What have you seen so far? We have seen different types like vectors, string on the heap, and ampersand, strs, which are borrowed references of those strings. We have touched the ownership and borrowing concepts in Rust. We can now put our code in different files and use it as a module, which has brought to us the concept of what we can do to expose those functions using the public and the private concepts. We have seen some other things that are going to find later in the playlist. So we're going to treat those points more in details later on. So focusing only on those points, like for example, the display error that we got in the last video. This time we are going to see what is like a class in Python called a struct in Rust. And like in Python, we have methods in the class. Rust structs can have also functions attached to it using implementations. First part, some explanations. And second part, we jump on the terminal with our Manga Kisa example. Please like and subscribe. Watch to the end. Let's get started. Structs and implementations. So struct is a keyword. It's like Python class. So you put struct, you put the name of that class, of that struct. Here is a rectangle that we're using as an example, which has two different properties with the same type here, U64, the width and the height. So that's how you define it. There's no semicolon at the end, so struct keyword is used to define a new struct. Rectangle, the name of the struct, and the fields width and height of type U64, unsigned, which means that it's only positive integers. Implement. So the implementation of the method, we're going to use the keyword empl, are used to add some functionality to the struct with some associated functions like class methods in Python. So using the keyword impl to add functions, methods to our struct, we use an implementation block. Let's check those implementations. So we have the struct on the left, and on the right side, we have the implementation to that struct. So we use the name rectangle, impl rectangle, and in curly braces, we're going to put the different functions. As you can see, there is no semicolons. So we're going to define a function area, which is going to take a reference. So here we use the same keyword as in the Python, self. So the reference of the variable is going to return a U32, but we can maybe put a U64 in our code when we're going to use it. After, it's going to use self width. So the self is referring to the struct, not an input variable to the struct. So self width multiplied by self height, which are the two fields present in the struct. And after, we have another function, which is square, which is going to take now an input variable, which is size. A U32 is going to return a rectangle. So we can say maybe a square, but it's going to return here a rectangle with the width and the height being the same. So using the same variable, which is the size. Impl rectangle begins an implementation block for rectangle. Fn area after you have the end sign itself, it's going to return a U32, defines a method named area that takes an immutable reference to self, which is the struct, and returns a U32, so a positive integer. So the unsigned self represents a reference to the instance of the struct. So here is clearly said. Explanation. So we're going to see a full example, which is here implemented directly into the main function. So we have fn main, which is the one which is found by the compiler. We create an instance of the rectangle. So we create a variable using the keyword let rect1 equal to rectangle. We call that instance. And after, we're going to be using the field of the struct and defining positive integers for the width and the height. Here there will be a semicolon because it's a variable that we have defined. After that, we're going to call a method. So we have implemented two different methods. We're going to call one using the println with the formatting. The area of the rectangle is, we put curly braces, square pixels, and we're going to call the rect1, which we have created the variable, which is instantiating the structure, having the variable, the field already having the different numbers, dot area. And after the dot area is going to be able to make the operation. And the other one, same, creating a square, let square, but this time we are going to instantiate it in another way, so that you can see also that you can use a rectangle. So you can use double colon. It's like a dot notation to access to that method square. We put the number 20, we close it with a semicolon, and after we're calling the area, so we're calling the other implemented function on the square method that you have created. So we get the area, which is going to be multiplying the width and the height, println the area of the square, we put the curly braces, square pixels, and after we just call square.area and we close it. So you see here in the second example, we create let square, which is going to just create a rectangle having width and height at 20, because that one is returning a rectangle. I'm just going to go back. You see here on the right side is returning a rectangle. As it returns a rectangle, we can call this one on it to get the area. So that's what we're doing here. So it's good to see those different mechanics happening. After, we're going to jump now into the terminal, and we're going to be commenting every single line, and we're going to be creating our own struct mangakisa. All right, let's have a break and jump into the terminal. Please like and subscribe. So struct, to create objects, we're going to create a file, nano struct and methods.rs. That will be our new module. Let's start commenting here. Struct, it's like a Python class. Okay. And we're going to start creating the struct. We use the keyword struct. We call it mangakisa. The room number. After here, we're going to add the different fields we're going to use U64, which is an unsigned integer, meaning that is positive integer. We have the capacity. We can add toilets, if there's any toilet, how many of those we have. We can use also maybe some different types other than U64. Book number, computer number. Now we have a comment. We can use here a string type. And we're going to use a boolean, Junko present, a bool that says yes or no. So true or false. So here we can comment this string like Python str, so like Python string. And we know now that Rust has also str, which is a different thing, which is a reference. So it's not the value, it's the reference of the actual value on the heap. Rust has a string also, but it is like a Python slice. So, for example here, from 2 to 7. Or the full string. If we use just a colon, this is like a full string. But it's still a slice. That's why we can use it also to reference the string entirely. We're repeating ourselves in different ways just to record that. We implement now the methods. I believe that you can actually create those methods in the struct. I haven't tried, but I'm just following the way I've seen people doing for the moment. But you can try. I believe the struct can implement methods like that, but I'm using here impl. That's what I've seen in the documentation. Let's use that. So now, like in Python class, we have methods. We can implement methods to the struct using the impl keyword. Let's do an impl, and after you use the name of the struct that you have defined. So we have used mangakisa, we put here mangakisa also. Now it's gonna recognize that and know that those functions here defined will be implemented for the struct called mangakisa. I'm gonna add an extra comment here. I'm gonna close the comments after, it's just for you to be able to read it. That's how it works. So you just put fn, you just keep adding some functions depending on how many functions you need to implement to your object. So vector in Rust is like a list in Python. So we're going to be using vector. We have our struct, and let's say we want to implement a function it's going to return a vector, like a list of every single field present in that struct. Let's make a method that turns the struct to a vector. So we're going to define the function using fn. We're going to call the implementation method to_vect. We're going to use a reference of self, so a reference of the struct manga kisa. We're going to return a vector having strings only. So every single field in the vector is a string. So we're going to have to turn those integers into strings or boolean. Use an existing macro to make the vector. So like a println, there is so when you see the exclamation mark, that means that it's a macro. So it's already implemented. You just use it. And for vectors, we have the vect exclamation mark that we can use, like a println exclamation mark. When you see an exclamation mark, it is a macro. So we can use it. If we need some more custom stuff, we need to do some more implementations. And import some packages also. But here we are going to keep it simple because we want to focus only on that. Having a struct and having those functions which are going to be implemented to that struct. Later on, the playlist will be going more into the details of those kind of implementation that you can put. So here we're using the macro vect. And we use the keyword self, which is the reference to the struct. And after we put the dot notation, room number, which is acceding to the field of the struct, we use the dot to string. So there's an underscore normally. Yes, like that. So we use this method here already implemented in the Rust that we can use. It's available and it's going to turn that field into a string. Right. I'm going to try to be a bit quicker. Let's copy and paste and just add self to string. Okay, and we're gonna just put the indentation. Perfect. We have those two here, and we're gonna do the same. So as you can see, the struct on the top doesn't have any semicolon. You just open the brackets, you define the fields inside with the types. You can have also a struct which has no field at all, and do your implementation later on. Here we go. So now we can close those comments. We have implemented in MangaKisa struct. It's MangaKisa. I did a typo here. Okay, that's the struct name. We have the different fields. We're implementing this function here to turn it into a vector using the reference of it. Just put here. So fn is like def. In Python, that's how it will be def and return list and str. Something like that. That's what we have created. So the ampersand is a borrowed reference. This is dealing with how memory is managed in Rust. But if you followed the previous video, so I refer you, just go to the previous video if you want to see more details into the ownership and borrowing concepts. We have touched it a bit. That's why we can use it here. The struct is the owner of those fields. So all those variables, say those fields. We just borrow those using ampersand, the and sign. To use those, okay, we can stop commenting. One more. So it's not in Python. It's good to know. Because in Python we have a garbage collector, which is going to take care of all those lower, I can say, lower level codes. Okay, now let's implement some more functionalities to our struct. So what we're going to do, we're going to add some more functions so that we can play with different fields. So we turned it into a vector with the first function. This function here is going to just calculate. We just take two fields and we're going to multiply one by the other. So fn calculate. We use the unsigned self to refer to the struct. We're going to return an unsigned integer u64. We refer to the field self.room number multiplied by self.capacity. So here I could have used a semicolon, but because it's the only line where we're doing the calculation, is going to return the result. So it implicitly returns the result. So we don't need here to use the semicolon. But in my case, I might need to put the semicolon everywhere, as I might forget it in some other parts otherwise, because I'm not used to it. Only when I'm in a JavaScript mode, maybe. On last method, so we play with the string now. Let's use the string field. And we're going to try to extend that comment. Use the reference of the string. Should I use here a mutable reference or not? I'm going to go like that for the moment. Self.comment clone. So as we're not using a mutable reference, we're going to be cloning the value behind this reference. So at that time, we'll be able to append to it. So we add in a plus, and here we're going to just append a sentence that we will decide after. I'm just going to come back here to put the sentence that is going to be always added when using this method, comment more. Let me open this so you can read with me. So .clone, you might need to go and read the documentation for that. The .clone is used here to be able to have let's say the variable which is behind the reference, and add to it some extra text, add to it whatever we want to add to it. Add to it the sentence. Clone variable to manipulate it. Let's go to the documentation. Clone, just type it to Google and it's going to bring you to the book and you read the book. Clone, that's how it's used. There's an example, a common trait, the ability to explicitly duplicate. So explicitly duplicate, it differs from copy. Copy is implicit, is inexpensive bitwise copy, while clone is always explicit and may or may not be expensive. In order to enforce those characteristics, Rust does not allow you to implement copy, but you may re-implement clone and run arbitrary code. So that's what we're doing here. We're using clone. So we have another variable and we can play with it. While the ownership of the reference variable hasn't moved. So we get a new variable. Okay, we're good with that. Let me comment here a little bit more. Just to close this case of clone. So clone will copy explicitly. That's what we've seen in the documentation. That's how they say it. The variable and not its reference. Byte. That's what the ampersand does. Just keep the reference of the actual variable, which is in the heap. So I believe that reference is in the stack, probably. So now we're going to be creating a function here that is going to be called from our main function. Now let's make a function that will use the struct and its methods to play a bit with it. So now you know how to create a function. You go fn, try to get out of your brain a name for the function. Reserve underscore manga underscore kisa. We're going to make a reservation. We're going to return a vector, a string vector. That's what we are going to return. And we're going to populate this function now. So let's comment a bit. Let's first we're going to instantiate the struct and create an object. Using the let keyword, you're going to call it Shibuya Manga Kisa Danger equal Manga Kisa, that's the name of the struct. There's different ways to instantiate it. This is the way we're going to use. Okay, so let's use the fields of the struct and create those values. So when you instantiate a struct, you can't omit any field. You have to use them all. Otherwise, you're going to get an error. Unless you have some of those fields being of a type of optional. But here we don't have any optional fields because we haven't seen it yet. So we need to use all the fields. So we had the room number, we put 354, the capacity 2, toilet there is 1, the book number 1984, computer number 98. Let's add a comment. We use a string, double colon from. This is to create the string. Let's say Saturday night reading books in Shibuya. That's the sentence. Now that we got that sentence, we can just check what we can add to it. We add a space. You are happy. And you go happy. Let's add this. So try to have fun while doing your coding and use the variables that you find explicit to you. That's explicit to me, and that helps me to, in a cool way, learn. That's it. Good environment. So here we got our instantiation. Junko present, we put true. Junko is present. And here we have instantiated this struct in a variable called mangakisa danger. We can also here add the type if we want and say that it's a mangakisa type, but Rust is gonna be able to infer it. Here, as it is a variable, we need the semicolon. Now we need to return it. We can return it now using those implementation that we've done, those functions. And let's first maybe vector, or let's calculate the capacity. So we use the keyword let, calculate capacity, name of the variable. We're going to use the variable here that we have created. So the type of that variable is mangakisa, which is a custom type because we created that struct. Dot calculate dot toString, because our vector is returning strings, because we're going to be adding it to the vector later on. So we use the method toString, which is available to use. It's same as a .clone. You don't need to import anything, you just get it out of the box. So here, calculate. That's what we have defined here. We borrow in the reference of the room number and the capacity. Implementation in Mangakisa. And the Mangakisa struct, capacity and room number. Okay, so now I believe that you got it. You know how it is structured, how it is done. Let's go back down. Reference of those fields. Because we borrow the reference of the struct itself, and we're returning a new 64. But our vector is, we're returning a string vector. So U64, calculate, but we want it to be a string in our final return vector. So we use the toString method. And now it's the calculate capacity variable has the right type, which is a string. We will be able to return it without any error while pushing it to the vector, while appending it to the vector. How are we going to append it to the vector? So now let's go into that step. We're going to let's create a vector using the method that we have implemented. Let's create a vector from the struct field. Here you see I use the keyword mut. Shibuya Mangakisa danger. That's what we have created. And I put underscore vect as the vector. I use that variable and I'm going to call on it toVect, which is the method that we have implemented. Let's comment more. I hope I'm not going to forget to close those comments. By default, everything is immutable. We've seen that before. Everything is private, everything is immutable. Right? So, as we are going to extend the vector, we use keyword mut because you want to modify it. Here we just define it. After we want to change the length of that vector that it contains. So make it mutable. Where is it? Here. So here, what we're doing, we just get the reference and return a vector string. But this vector string is just representing the struct fields. Using it just like that, we can't add anything to it. That's why we're using the mut keyword. So we'll be able to mutate that variable, that vector, and add some different some different things in it, but it has to be of type string. That's the only obligation that we have. So now we've created that. We can do the gymnastic. Let's now add more variables in our vector. Okay? In our mutable vector, to be precise. Extendable. You can also truncate it. You can make it shorter. Truncable. I don't know if we can say truncable. Truncable. Vector. Let's get this variable. Let's use the method push. That's how you append to it. So the result of the capacity that we have calculated. So here I added two string. I probably don't need it because it's already a string. But I think I need it because I'm using push. Let's not use it. Should be fine. Because you have push and you have another one is push underscore str string. So in one you can put strings, in the other one you can put I think characters. So here calculate to string. So we got the string transformation. Using push. Just going to comment here to make it clear. Use keyword push inside. That's the type string. To add to our vector. Some values. Let's close those comments. I'm going to close the other comments later on. I know I forgot some. Now we got our struct has been transformed into a vector. We made a calculation just before. We've pushed the result of that calculation, transforming to a string into that vector. And now we're going to use the third. Let's close those comments. Good. And we're going to use the comment more here on this method, this implementation. We're going to do the same gymnastic. Let's use our last method. We're going to call it let keep commenting. Shibuya Mangaki Danger. Instantiation of the struct with all the fields having a value. We call on it .comment more. And push it to the vector. Okay. So we're going to push it to the vector. Just copying this line, changing the variable here to keep commenting, and we push it to the vector. Do we need to use toString here? Let me just write something here. This is already a string. That's why we can push it directly without adding the .to_string after comment more. And now we're going to implicitly return the vector. Just get the vector, we return it. We don't use semicolons because it's the last line of the function. Return the vector, so no semicolon. Okay, let's close this. Now you know. We need to do a little bit more. The struct has to be public. All the fields of the struct have to be public because we're using them all. We need to make those public. So we're going to put pub, the keyword, in front of every single field of the struct. Pub and pub. Good. Here we're going to put public into the function that has been implemented to the struct. Public here also. There's a function. So everything here is public. Implementation, we don't need to put on the implementation. Inside, yes, you can put it inside. Could have done like in the video, the previous video, where we just put the public into the function that we have used in the main method, in the main .rs. But here the struct need to be public. So that's the name of the module, the file name. Struct underscore and underscore methods. Let's comment this out. That's what we've done last time. And in the main function here, we're gonna call this the method name. Reserve manga kisa, something like that. Okay. Cargo run. We're not scared anymore of the compiler, we just read. And println. So first, here we need to put to use the debug mode to because we haven't implemented the display. After here, function with similar name exists. So yes, that's the typo. I need to fix this. Let's go back in. It's not Managakisa, it's Mangakisa. Okay. Now we're good. We run it. And here we go. So we got all the fields, and we have the additional fields, the one calculating, and the other one extending the string. So those are the 254 and 2. One capacity, 190. Okay, 98 here. We got through. Junko is present. The Saturday night reading book in Shibuya. That's the initial sentence, which has been now changed. You are happy, and you go happy, and we have here 708, which is the product of 354 multiplied by 2. Okay, we have seen how to make a struct, which is like our Python class, and implement some methods using the keyword impl and defining functions that will be available to use for the struct. We have made some little arithmetic operations and used the borrowing and cloning concept on a string variable and extended the string on the heap. Cool, interesting. Let's keep learning Rust. We will see in the next video some conditionals, but in a special way. And we will introduce, I will introduce you to the Rust enums. Hope that you like this video. Please like and subscribe, and see you next time.